Hello everyone. This is a summary video on the lesson Arithmetic Sequences and Series. So first of all, let us understand what is an arithmetic sequence. An arithmetic sequence is a sequence in which the consecutive terms of the sequence has a constant difference. What does it mean? It means that if I have a sequence with the terms A1, A2, A3, A4, etc. The difference between, let's say, if I was to take A2 minus A1 is, the difference is D, then A3 minus A2 will also be minus A3 equal to that's two meters from so A1 is taken as 0.37, A2 is 0.6, A3 is 0.83, and A4 is 1.06. Now when you subtract A2 minus A1, that means 0.6 minus 0.37, you will get the value as 0.23. And if you subtract 0.83 minus 0.6, again you will get the value as 0.23. So the thing you can notice is the difference between the consecutive terms remains constant. The meaning of the word consecutive is coming one after the other. Okay, like A2 comes after A1, A3 comes after A2. Now recall that linear functions also have a constant first difference. Linear functions, as you studied before, have a constant first difference. And also, if you graph this table here, the values with their position, that means 0.37 is the first term, so its position is number 1. 0.6 is the second term, so the position will be number 2. 0.83 is third, so position is number 3. So if you graph this on the x-axis and this on the y-axis, your graph will be a linear graph as shown here. As you can see here, if you join the points, it will be a linear graph. So thus you can think of an arithmetic sequence as a linear function with sequential natural numbers as the domain. That means the domain starts from 1 till infinity. The x values, we start from 1 because we start the first term as a1. Example 1 is identifying arithmetic sequence. So you have to determine whether this given sequence is arithmetic or not. And if so, find the common difference and the next term. So to determine whether it is an arithmetic sequence or not, we have to find the differences between the consecutive terms. So here, the terms are -4, -4, -10. So if you see the differences, you will get them as 6 -4 -10, which is -4 plus 10, which is equal to 6. And if you do 2 minus -4, again you will get 6. Then 8 minus 2 is also 6, and 14 minus 8 is also 6. Now, since the difference is constant, we can say that it is an arithmetic sequence. And as we know that the difference is 6, so the next term, to find the next term, I just have to add the difference to the last term. So 14 plus 6 should give me the next term as 20. In this question, minus 5 minus 2, which is minus 5 plus 2, which will give me the value as minus 5 plus 2 is minus 3, then minus 11 plus 5 is minus 6, minus 20 plus 11 is minus 9. So as we can see from here, the differences are not constant. Since the differences are not constant, we can say that the sequence is not arithmetic. So there are more examples if you go through. So here the common difference is minus 0.7, so we can say that it is constant and it is an arithmetic sequence. The next term would be minus 0.9, and just add the common difference. So minus 0.9 plus minus 0.7, which is minus 1.6. Here the difference is not constant, and hence it is not an arithmetic sequence. Now, what did we understand from solving the example 1, finding the next term? Each term in an arithmetic sequence is the sum of the previous term and the common difference. The sum of the previous term and the common difference. Okay, that means if I'm to find the fourth term, let's say A4. So the previous term will be what? A3 plus the common difference. So from this I can get a recursive rule that an is an minus 1 plus d. Okay, I can also develop an explicit rule for an arithmetic sequence. So if I go to the first example of the cost of mailing letters, if I check the values, my first A1 was 0.37, then A2 was 0.6. If I try to find a rule in them, I can see that the first one is A1 equals 0.37 plus 0 multiplied with the difference. A2 is 0.37 plus 1 multiplied with the difference. A3 is 0.37 plus 2 multiplied with the difference. So from here, I can notice a pattern that AN is 0.37, which is my A1 value, plus N minus 1. Here it was 2. Here it is the second term, but when I'm multiplying with the common difference, I'm using N minus 1. So multiply with 1. Here if you see the fourth term, but I'm multiplying 3, which is N minus 1 again. So AN is equal to A1 plus N minus 1 and 0.23 was my common difference, which is D. So this is the explicit rule for all arithmetic. Find the nth term an of an arithmetic sequence is given by an equals a1 plus n minus 1 into d, where a1 is the first term and d is the common difference. Example 2, I have to find the nth term given the arithmetic sequence. So I'm given the arithmetic sequence and they ask me to find a particular term of the sequence. So first of all, what are the things I need from the formula? So an is a1 plus n minus 1 into d, right? So I need a1. I know which term, I know n. It is the 12th term, so n is 12. I have to find the d. So I need a1 and d from the sequence. So what can I see? Find the common difference. Common difference is second term minus the first term, or third term minus the second term. The difference between two consecutive terms. But you have to take the one that comes later, the latter minus the prior. Okay? So 14 minus 20, not 20 minus 14 for this series. In step 2, evaluate by using the formula. Formula we know, the general rule, an equals a1 plus n minus 1 into d. Substitute a1. a1 was 20. And n, as I know, in the question they asked me to find the 12th term, so n is 12. And d I just found out as minus 6. Substituting, I will get a12 equals minus 46. So the 12th term is minus 46. You can check by continuing the sequence and seeing the 12th term, whether it is 46 or not, minus 46. Now in this question, they asked me to find the 11th term of the arithmetic sequence. Similarly, first find the common difference. So the second term minus 5 minus the first term minus 3. So minus 5 minus minus 3, which will give me minus 2. Step 2, evaluate using the formula. So I know that a1 is minus 3. From the sequence, it's very clear a1 is minus 3. And d I just found out as 2. N I know that it is 11. Substituting it into the formula, I will get a11 is minus 23. Similarly, more questions. The method is exactly the same. Find the common difference. You have a1, you have n, substitute in the general rule, get the answer. Now, in this question, example 3, I have to find the missing terms. Find the missing terms. So I have a1, which is 17. I have a5, which is minus 7. So I have a5. Using the general rule, I can find the common difference. How is that? Substitute a5 as minus 7. That is, it becomes, so I just substituted here a5 as minus 7. So here is minus 7. Then a1 plus n is fifth term, so 5 minus 1 multiplied with d. I need to find this d. If I solve this, what do I get? I get d is minus 6. Then once I find d, there are two ways of getting the answer. Since I have the first term, I can just simply add the common difference to this. That means 17 is there, so I will just add plus minus 6, which will give me 11. And then after I get 11, I will just add plus minus 6, which will give me 5. And then I have 5, so I will just add again plus minus 6, which will give me minus 1. You can also use the general rule of an by substituting a1 and d values for the given terms. Now in this question, I have a1 as 2 and a5 as 0. So just like the previous question, I will substitute in place of a5 0 and write the general rule to find the common difference, which will give me common difference as minus half or minus 0.5. So I can just add it. I can just add the common difference. I can just add the common difference to my previous term to get the next one. So 2 plus minus 0.5 will give me 1.5. 1.5 plus minus 0.5 will give me 1. Then 0.5 and then 0. You can also use the an formula. Because arithmetic sequences have a common difference, you can use any two terms to find the difference. What does it mean? So they have a common difference. So if I know any two terms of the sequence, I can use it to find the common difference. How do I do it? Let's say I have A8 is 85 and A14 is 157. So A8 is 85. What is A8? A8 is basically means A1 plus n minus 1, which is A8. A1 plus n minus 1, which is 8 minus 1, multiplying with d. Here, I multiply with here 1 plus d. This I have two ways I use, so I can so let's say I have d is a1 taking it to the other side. 1 is equal to 1. So I got A1 as 1, from A5 equal to minus 1, and D is so 1 plus 5 presentation. So AN is A14, and I can consider A8 as my A1. Okay, I can consider, that means instead of starting from A1, I can consider A8 as A1. So I can substitute. So instead of doing n minus 1, I can do n minus 8. That is 14 minus 8 to get the value of D. So the answer will be same. It is just the difference of methods. You have two methods. You can use either elimination method or substitution method, whichever is easier. So here you have to consider A8 as your first term, okay, and your nth term will be considered as A14. So when you're applying n minus 1, instead of doing n minus 1, you considered your first term as the eighth term. So we'll do n minus 8, that is 14 minus 8. Then for finding A1, you just substitute the value of D in any of the equation and get the answer as 1. After that, you can apply in step 3 in the general rule A1 and D values you have, just apply it to get the value for A5. Similarly, in this question, for this question, it is really simple because your A2 and the terms given are A2 and A3. So you can just subtract A3 minus A2 to get the value of D. Or you can use the steps from the previous question, considering A1 as A2 and AN as A3, substituting one in place of another to get the value of D. So your AN is A3. AN is A3 and A1 is A2. So instead of doing n minus 1, you do 3 minus 2. And A2 value is given to you. Just substitute that from here and then find the value of D, which is 12. And then substitute this value in any equation of, so A1 is minus 45. And in step 3, since we are asked to find the 11th term, just apply the general rule. You have A1 and you have D, substitute the values. You have N as 11 because it is 11th term, so N is 11. So the 11th term is minus 25. So arithmetic series is what? Arithmetic series is the indicated sum of the terms of an arithmetic sequence. So when you start adding the terms of an arithmetic sequence, The sum you get is known as an arithmetic series. That means if I start adding a1 plus a2 plus a3 plus a4 until a given term an, I will get the sum of the arithmetic sequence, which will be known as the arithmetic series. We can derive the formula for sum of an arithmetic series, Sn, that is sum of n terms, in the following way. So by adding them in reverse. So you may go through the derivation and try to understand it. The main thing we need to know from here is the rule of Sn. So Sn is equal to n multiplied with a1 plus an divided by 2. N multiplied with a1 plus an divided by 2. So if we go through this example here, as per the formula, it is a1 plus an. If you see the sequence 2, 4, 6, 8, 10, this is my a1, 2, and an is 10. So I will apply the formula, and how many terms I have? 1, 2, 3, 4, 5. So n is 5, a1 plus an divided by 2. So my answer is 30. Also, if I add these numbers, one after another, plus 12. So in this question, they asked us to find the sum of 18 terms. So first of all, I need to find, I have a1, I have n, but I'm still missing an. I don't know what is an. Now, since they said me to find for 18 terms, that means I have to find for a18. My anth term is the a18th term. So I know the common difference is second minus the first, so 2 minus 13, which is minus 11, and a18 will be 13 plus 18 minus 1 multiply with minus 11, applying the general rule of an. The answer is minus 174. Now I have a1, I have an. I can apply the general rule of finding sum of an arithmetic series, Sn, sum formula. So here it is not a2, it is an. a1 plus an divided by 2. So I got an as minus 174 and a1 is 13. So add them, divide by 2, and the answer is minus 1449. Now this is something to understand. These sums are partial sums. That means I cannot find the complete sum of an infinite arithmetic series because the term values increase or decrease indefinitely. So that means it will either increase to infinity or it will either decrease to minus infinity. So the sums that I find are known as partial sums. So in this question, the symbol sigma, the symbol is known as sigma. It indicates sum. So they are asking us to find the sum of terms 1 to 15. So that means I have to find S15. And this one here is basically the formula for my nth term an. So if I just apply or replace the value of k with any number, and the 15th term will be 5 plus 2 multiplied with 15, because as I said, this k basically denotes my n. Okay, this k here, it denotes the n, the position of the term. So I have a1, I have a15. I can just apply the formula of sum, the sum formula, and find s15. Again here, this is an, or a15 in this case. So the answer is 315. Coming to example 6, problem solving application level. The center section of the concert hall has 15 seats in the first row and 2 additional seats in each subsequent row. How many seats are in the 20th row? So we need to analyze the question and understand the given data. So they said 15 seats in the first row, which means I'm given my A1 value. The first row means it's a position, first row, n. N is equal to 1, first row, and the A1 value is 15. And 2 additional seats in each subsequent row. That means there is an addition of 2 seats at every row. Okay, so this is basically the common difference, D. And how many seats are there in A20? So n plus n is 20 minus 1 2. So it is 15 plus 8, which is 50. So there are 53 seats in the 20th row. Now they're asking me in the next part, how many seats in total are in the first 20 rows? So this question indicates how many seats in total are in the first 20 rows. First 20 rows means from A1 up till A20. And total means basically they're asking me the sum. So I have to find S20. I have A1, I have A20. I can apply my Sn formula directly to get the sum. So I have 680 seats in total. And that's it for this lesson. Thank you very much.